The stars, the lives that stars live. Now, I know that a star is an inanimate object, but I've been studying for them for years now, and I think they almost have personalities and they live their lives. Stars actually come into being and then they kind of fade out, or they go out with a bang. But so I know stars are not an animate object, but we can talk about them actually being born much the same our sun was born. So I don't know if this looks like a deja vu slide down here, but we called it the condensation theory, and we said that our sun started in a solar nebula, and then basically the solar nebula got some rotation here, and the matter condensed in the center, and it got hotter and more dense, and actually then you can kind of see here where we start to get these protoplanets. We talked about this earlier. And then down here, the sun, this last figure down here, the sun has turned on. The sun became alive. Well, I know it didn't become alive, but we say a sun turned on or was born when it begins thermonuclear fusion in its core. Remember, this is a nuclear fusion here. Hydrogen plus hydrogen goes to form helium. That's what our sun is doing. So that's the birth of our sun and the planets. And what we're seeing actually is that there are stars that are in various stages of this life that we know our sun went about to be what it is today, our sun and the planets. And remember, we said that most stars actually also have planets around them. But now picture this. I'm going to take this down here, our solar nebula, and I'm going to go ahead and I'm going to make the nebula bigger. I'm going to make it what we call a giant molecular cloud. So it's possible within the same cloud or giant molecular cloud or nebula, these kind of regions actually can do a very similar process to what our sun did. And in that case, our sun has siblings. Okay, so a lot of stars can be born in kind of the same large, what we call a giant molecular cloud. And they're oftentimes stimulated about the same time, and in doing so then they kind of take on these similar characteristics of being a different age. Oh, my thing's not forwarding. Forward. Okay, there we go. So here we have a couple of different types of stars being born all at one time. We have, they form what we call clusters. And here we have an open cluster, this first one right here. This actually is an open cluster. This is beautiful. This is a picture of the Pleiades, or the Seven Sisters. And sometimes it's mistaken for the Little Dipper. Okay, but this is an open cluster. These stars were born about the same time. In fact, can you see kind of some of the nebulosity material kind of between these stars? That is so cool. These other stars were born about the same time. Now these are globular clusters. This is an example of a globular cluster, of stars. And there's different globular clusters out there. They all kind of have their own personality. But can you see where they look like kind of a sphere? They're all balled together. They have kind of a hard concentration in here and kind of goes out. Globular clusters generally are old stars. So they were stars that were born about the same time. So another thing, this is kind of fun. Up here I have a photograph of two stars. I'm not sure, but I think that that's Albireo and its companion star. Albireo is in the constellation Cygnus the Swan. And most stars actually have a companion star that was born about the same time, and they actually are gravitationally associated with each other. There was, I don't know, some movies actually kind of show a planet with two suns, and it's possible. It is definitely possible. So this is an awesome field of view of stars. Now, just kind of glancing at all these stars, you probably notice that there are some differences in them, just visually looking at them. For instance, they are shining different colors. We kind of have some blue ones, some red ones, some green ones, some yellow ones, the different colors. And the different colors are real. It's not an artifact of just kind of your vision going wacko. The other thing is they shine with different intensities. If my slide will advance. There we go. So some look brighter and some look dimmer. Now, the reason they would look brighter or dimmer can be because they are closer to us, they look brighter, or sometimes they look brighter because actually they are shining more energy. And my slide is trying to catch up here, hopefully. Okay. Now, the color that they are and how much energy or how bright they are actually is an indication of what's going on with that star. Specifically, what's going on in their cores. Now, remember when we talked about the sun, that's where we said actually the energy is being created in the core of the sun, and so the energy is created in the cores of these stars. So there's different chemistry to kind of give them different colors, different intensities, and also I'll try to kind of convince you of this, but the colors they are kind of an indication of what stage of the life they're in. So we can broadly take stars and break them up into relatively high mass stars and relatively low mass stars. So starting with the lighter stars, and our star is actually a lighter star. Okay, this is our sun. What do they have in common? Well, now I'm kind of being very general there. We can break out low mass stars into kind of even more characteristics. But in general, they can oftentimes have a red color. They live a lot longer, even though they are low mass. They live a lot longer, and they will end their lives relatively quietly. Our sun will end its life just as what we call kind of a planetary nebula. So those are low mass stars. Well, contrast that to high mass stars. So high mass stars, when we're looking in this field of different stars, for instance, the ones that are bright and have kind of a whitish color, that whitish actually, if we kind of track it back, it's oftentimes more of a blue, but I'll go ahead and say white. Okay. Now these stars actually will live, even though they're more massive, they have more mass to start out with, they're going to live shorter lives because they're cranking through that mass. They're burning it in a sense and shining. And these massive stars are the ones that end their lives explosively. If you've ever heard of a supernova, okay, that is, in one case, that type of explosion is a massive star ending its life.